Hello everyone and welcome back. So in the previous video I said I'd talk a little bit about garbage collection and static in this video. So garbage collection is basically a freeing up of resources. That's if you think about it that way. So for instance, this sounds really fundamental, but in my previous job a long time ago, we used a database, and if one person used it, it would lock everyone else out. So if you're locking resources, or if an app uses something and doesn't close the file, then it must terminate before all the other apps can use it. That's kind of the fundamental way of explaining it. So if we say in Java, then there are certain system resources that can be freed up, and they're usually freed up in Java within the Java virtual machine already automatically, so we don't need to do anything. However, with the garbage collection, to reclaim a lot of the memory, it has to have no more references to that memory, and then it's eligible then to be collected. Certain things can happen within garbage collection, so resource leaks other than memory leaks can occur, and then so memory leaks that are common in other languages like C and C++, because memory is not automatically reclaimed. So they're lower level languages, and we're looking at a higher level language. And then they're less likely in Java to happen because of this. There's another part of Java which was part of the java.lang, and it was called finalize. And what you could do was it was meant to free up some resources and to allow the garbage collector to terminate some of the housekeeping that was going on. But actually we should never use finalize. It's better to use what's called auto-closable objects to reduce the likelihood of resource leaks. When you use then it like try with resources statement, then it uses this to see if it's finished with the object and then comes back. So now we're going to look at static, and that's related, but I'm going to show you an example first and then talk through some of the stuff. So let's have a look at the employee one. We've already discussed the employee with the date example when we were creating new objects, and in not the previous video, the one before that, so I'll put the link below. But we'll have a look at that now. Okay, see you in a second. Hello again. So here's our employee and our employee test example that we did already. I've just added in a couple of lines because we're going to talk a bit about static. So a static field is a class variable. So if we have a static here, it's basically one copy of it. So with an employee object, we can have multiple employee objects and then use the same, in this case, integer count for all of the multiple employee objects. So one of the reasons behind this is that one, you don't need to create an object. It's already the static variables and members are already available. So an example would be the math class that we've already used, and we've used the math.py and math.max, and we don't need to create a new math object to use some of the static methods that are already there. So it's really useful. The other reason is, for instance, in a video game, and I'm a player. Usually it's and the player needs to know how many other players are there if, let's say, they're going to be attacked or something. So if they're only going to attack if there are 4 players or 4 other players, if there are more, then they don't attack. So each of those players need to know the number of how many players that are in the game, but the number is the same for all of them. Otherwise, if the number changes for each one, then it's just going to be really using up a lot of memory, using up a lot of space, really inefficient in every regard. And then also, not only does it save space, but it also saves time in our side, because we don't need to go through any of that. So now we'll just go through the example, and I'll talk through some of this stuff as well. So the number one thing though is that a static class member exists even when no objects exist, and that we already looked at an example with math.max class, the math class, and using .max method, and that was a static method. So anyway, here we go. So we have private static int count, and I want to count how many employees there are, and so I've just put in an incrementation here and then a get count. So obviously with the private, we have to have a get or an accessor method with that. So with the accessor method, then we have to return an int, and because it's static, it has to be labeled as static, and here is also static. So the count is only when the constructor is called from the other object, from the other employee test even, then it will increment. So here we have employee test then, and I've just done out system.out for employees before instantiation. If I just close maybe the Project Explorer, there we go. So we have our system.out here, printf, employees before instantiation, so it should be null. Now, here's the thing about static methods. We can access the static method without creating a new object of employee, right? So we don't need to create new. It doesn't need to have a different name within, it's not a copy within the class. So here we just have a direct capital letter for class name dot whatever the method name is here. And that's accessing the static methods. It's the exact same as what we had a look at before, math dot, and we could access all of these static methods that are available in math. We don't need to create a new math object, and it's capital M for math. If we're creating a new math object, then of course we would do math equals new math, and that would be our new math object. Now it takes in certain constructors with it, and it's not visible because it's static anyway. It's part of the API. So that's just an example. So here we have employee, lowercase employee, new employee, and then we have our birth, same as before. And then I just create a new output here to show the get count of the class variable static get count. So if I just play and show you, so we have our date. Let's clean it up a little bit so we don't print out all of this all the time. So I think we have a lot of printing of printed statements that we have every time date is called, every time employee is called, and stuff like that. So I'm going to take away employee 1 and employee 2 for a second and do it again. And so now we have every time the date is called as well. So if we go back to our date and take out some of these print as well, we'll just do that for the moment. Now, so we have employees before instantiation, obviously null because we don't have any employees instantiated. There's no new objects. Here is employee object 1, the first one, the second one, and then after instantiation is 2. So we can also do one other thing here, which is very useful, and that is to show employee 1 dot get count, and then we can also do the same here for the other employee. I'm just going to bring that up to the previous line, make it nice and neat, but I'll also bring it because I know you want to see it. Now it will give you a warning because we're accessing a static int method from a non-static context as well, but that's okay in this instance, it's fine. We can press play and you can see here that employee and employee 1 both know that there are 2. So they're both aware of the number of employees that are there. I'm going to create another one, another even 2, 3, and we will do the same here for 2, 3, 2, 2, 3, 3. Now the naming conventions in this case is not the best, but we will work on that as we're going as well. And when you're in a larger group, we are going to need to know better naming conventions within Java as well. So here though, for demonstration purposes, it's pretty nice. You can see employee 2 then and employee 3, and you can see how many of the employee constructors are used. So you can see there's 4. Everyone knows now that there's 4. Because I've called it 4 times, I've made 4 new objects based on the employee constructor here that's been called. So that's it for static. It's really nice, it's really useful. You're only using 1. You're not creating a new copy. It's just you're using it within it. It's actually it's already there before you need to create a new object. So it saves a lot of space, which we already spoke about. Okay, so that's it for today. In the next one, we're going to talk a little bit about big decimal as well, and then move on to the more detailed stuff. Yay! Okay, thanks for watching. Please subscribe to my channel. If you have any feedback, leave a comment below. Thanks for watching. Bye.